Hello everyone, welcome to Hometown Tea Distribution. Today, I am your official tour guide, Daniel Eating. And without further ado, let our journey begins. At the end of this video, the viewers are hoped and expected to be able to identify the purpose and formula of critical values for tea distribution, solve for the critical value with speed and accuracy, manifest the values of mindfulness and analytical skills, and relate the concept of critical values for tea distribution in real-life situations. Let's get to know what is the critical values. Critical values are the numbers on the borderline that separates the test statistic values in the rejection and non-rejection regions. It describes how far from the mean of the distribution you have to go to cover a certain amount of the total variation in the data. Before moving on to the following location, here are the 4 essential things you need to know to identify the critical values. Let's start first with the degree of freedom. The degree of freedom is the number of values that are free to vary after a sample statistic has been compiled. They tell us the specific curve to use when a distribution consists of a family of curves. To get the degree of freedom, you must subtract the sample size n with 1. Moving on, confidence level is a range of values that estimates an unknown population parameter. Now, alpha error. Alpha error is the probability that a confidence interval will not contain the true parameter. To get the alpha error, you will subtract 100% or 1 with a decimal version of the confidence level. Lastly, the t-distribution table shows the critical values of the t-distribution. To use the table, you only need to know the 3 values: the degrees of freedom of the t-test, which is placed here on the left side, the number of tails of the t-test, 1-tailed or 2-tailed, and the value of the alpha error. This large space will be the value of the t-distribution. Now, since you already know the crucial terms, we can proceed to the long-awaited area, the problem solving. Number 1. Find the critical value for t for a 95% confidence level when the sample size is 15. The first thing to do here is to determine the alpha error. Using its formula, 1 minus 0.95 is equal to 0.05. Next, identify which of the 2 tests must be used. The term 2-tailed corresponds to the estimated values of parameters that can manifest from both ends of the distribution. It is also possible that if all deviations only manifest from one end of the distribution, then the 1-tailed test will be used. Since the problem does not indicate a direction, it is a 2-tailed. Then, find the degree of freedom using its formula. So 15 minus 1 is equal to 14. Now, locate the intersection of the degree of freedom and the alpha error and the tail distribution. So, the intersected value in the table is positive and negative 2.145 since it is 2-tailed. Now, illustrate the critical values in the standard normal curve. Find the positive 2.145 and create a line here. And negative 2.145 here serves as the left and right boundaries. Number 2. Find the critical value for t for a 10% alpha error when the sample size is 25. First, we identify the given problem. As you can see, the given was an alpha error instead of a confidence level, but no worries, the process is just the same. Since the alpha error is already provided, let us just turn it into a decimal form of 0.10 or 0.1. Then, solve for the degree of freedom. 25 minus 1 is equal to 24. Next, locate the intersection of the degree of freedom, which is 24, and the alpha error of 2-tailed 0.10. Now, the critical value is positive negative 1.711. Place the critical value to the standard normal curve, and this will be the boundaries of the confidence interval and the rejected region. Lastly, number 3. Find the critical value for t for a 1% alpha error to the right tail when the sample size is 10. As you can see here, there is a direction with 10, which means this is a, yes, 1-tailed. When doing 1-tailed, the process is just the same with 2-tailed. However, you will need to navigate where the 1-tailed alpha error is placed and the df when finding the critical value later. So, identify the alpha error, which is 1% or 0.01. Then, solve for the degree of freedom. 10 minus 1 is equal to 9. Now, locate in the t-distribution table the intersection of the degree of freedom 9 and the 0.01 alpha error 1-tailed. And here it is. The answer is positive 2.821 because the sign of the alpha error will follow the t-score. Finally, graph the critical value in the standard normal curve, and this is the final answer. To sum it up, critical values are the boundary lines that separate the values in the test statistic into the rejection and non-rejection regions of a null hypothesis. In life, we can relate critical values as our boundaries, which serve as basic guidelines to establish how others can behave around us. Life throws stones at us that challenge our abilities to think, act, and speak rationally, which sometimes we can offend someone or we are the ones being depleted. This is why we must acknowledge everyone's limitations and treat them with empathy and respect, as we can overstep the line like the critical value we aren't supposed to enter. And keep in mind that setting boundaries in our lives are also a form of self-love. Learn to say no and protect yourself when you know it is no longer healthy and feel you're being exploited. Everyone has their own struggles that we know nothing about. Let's always be mindful of everything we do and say. And as our journey has come to an end, I hope you enjoyed our short trip to the Critical Values City. That's all for this video, and this is Daniel C. Eating. Make your decisions right and acknowledge the visible boundaries that critical values. Thank you for watching. Bye!